Hello, Honors Algebra. Mr. Lawrence here with your next flipped lesson. This one will deal with two things. One, operations with rads, and two, solving equations with rads. Let's start off with operations with rads. Let's say we've already talked about like how you can't do rad 3 plus rad 5, right? That those aren't like terms, that you have to have the same amount of rads. Okay, excuse me, same number under the radical to be able to combine them using addition and subtraction. Well, how about multiplication and division? What if you have something like, say, rad 3 times rad 5? Well, part of you is thinking that that should be rad 15, and you are absolutely right. That is rad 15. All right. Now, it actually gets a little more useful like this. What is rad 2 times rad 2? Well, some of you want to say rad 4, or you could think about it as rad 2 times 2, and looky here, you got a date. These two can leave the house on one date, and that can simplify to simply plain old 2, right? Because I ended up with a perfect square, or a date. If I have something like this, say rad 10 times rad, I don't know, let's go with 8. Now, I could call that rad 80, which it would be, but I could also think about it as 2 times 5 times 4 times 2. And I've got this pair of 2's here and here that could leave the house on a date. But I also have this 4, which I know is 2 times 2, so I could have another 2 leave the house on the date, and then a 5 would be left out front in the house, and I'll have 4 rad 5. Okay, so I can think about it lots of different ways. I can think about it as rad 80, but in which case I'm going to have to break it down. All right, and I might know that it's 16 times 5. Then again, I might not, but it's 16 times 5, 5 is prime. I got a perfect, got a pair of 4's here. And then I can break it down to 4 rad 5. The 4's leave the house, the 5's left at home. All right, so when you're multiplying rads, you may not want to actually multiply. You may want to break them down into factors, make it easier. Now, one thing I think is really cool, let me get a little more room here, is when I have, say, square root of 16/81. Well, this is the same as the square root of 16, rad 16 over rad 81, which is the same as 4/9. I just took the rad of 16. Yeah, so rad 16/81 is the same as the rad of 4/9. And you can check that. 4/9 times 4/9. 4 times 4 is 16. 9 times 9 is 81. So sure enough, the rad of 16/81 is 4/9. Okay, now you have to be careful in situations like this. Let's say we have rad 8 over, let's go with rad 28. Okay. Now, if I do that, I know that 8's going to break down to 2 times 2 times 2, right? And 28 is going to break down into 2 times 2 times 7. 4 times 7, right? So I got a pair of 2's that can leave the house. My numerator is going to look like this. My denominator's got a pair of 2's that are going to leave the house. And my denominator, so it'll look like that. Well, I'm not done with this problem because 2 over 2 cancel out. And I'm left with rad 2 over rad 7. But we never, 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 did I say we never? We never leave a rad downstairs. We never leave a rad downstairs. To get rid of that rad, I'm going to do what's called rationalizing the denominator. Meaning I'm going to take that irrational number and I'm going to turn it into a rational number. It's real simple. I've got a rad 7 downstairs. I'm going to multiply by rad 7 in both the numerator and the denominator. When I do that, my denominator turns into 7 because it would become rad 49, and 49 is 7 times 7, so it breaks down to rad 7. My numerator will turn into rad 14. And there we go. Now some of you are thinking, oh, I should divide the 14 by 7. Absolutely not. That's not a 14. That is a rad 14, or the positive square root of 14. So you can't divide it by 7. It's not going to come be 2 over 1. Okay, that's called rationalizing the denominator. Let's look at another one like that. Let's say we have the rad of, I don't know, 9 over, say, 17. Well, I can break that down and say that's the same as rad 9 over rad 17. And then I can say that's the same as 3 over rad 17, right? Because rad 9 equals 3. But here I have a rad in the denominator, and I never, 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 never want a rad in the denominator. So I'm going to multiply by a very special form of 1. Rad 17 over rad 17. When I do that, my numerator becomes 3 rad 51. Why didn't I multiply 3 times 17? Because they're both not in rads. If they're both out of the rads, I can multiply. If they're both in the rads, I can multiply them. If not, I'm just going to, oh, I wrote 51, didn't I? Should be 3 rad 17 there, sorry. Okay, so let me fix that. Should be 3 rad 17. And the denominator will be rad 17 times rad 17, which comes out to be, I don't even need to multiply. I know that it's 289, but look, a pair of 17s can leave the house. And then I'm going to check and see if I can simplify here. They're both out of the rad, but 3/17 does not simplify. And so that problem is done right here. All right. Here, let me give you a couple to try on your own. Okay, there's 4 examples for you. You can go ahead and pause the video and write those down. When you're done with them, go ahead and unpause the video and you'll see my solutions. If you're still watching at this point, I assume you want to see my solutions. I'm going to start with number 1. I know that the same as rad 50, but I also know that's the same as 2 times 5 times 5. How do I know that? Because 10 is 2 times 5. So this is going to simplify into 5 rad 2. And there's my solution to number 1. Number 2. What do I do with the 3 and the 2? Well, I'm going to multiply them. And inside, I'm going to have a 6 times, and I'm going to break that 12 down into 6 times 2. So I have another pair of 6s here. This pair of 6s can leave the house out on one date. But there's a 6 out front. No, it's not going to be 66 out front. That would be silly. It's going to be 36, because these 6s leave the house and have a 6 times a 6, which is where I get my 36. The 2 is left in the house washing his hair. There you go. 36 rad 2 is the simplified answer. All right, now, number 3, I'm going to do 2 different ways. Okay, first, I'm going to break it down and say, you know what, that numerator is the same as 9 times 2. And the denominator is the same as 6 times 6. All right. The numerator will simplify into 3 rad 2. The denominator will simplify to 6. 3 over 6 can simplify further into 1 over 2. I didn't write the 1 here. See that 1? I didn't put it there. But, oops, I lost it. But I could have. Now, we are far enough along in our math careers that we should not be writing 1s in where they don't belong, where they're unnecessary. And there is a simplified version of rad 18 over 36. Now, I am going to do this another way. Okay, let me change colors here. That is one good solution. That is one good way to do it, and that is the answer. Now, another way to do this would be to simplify that 1836 and say, you know, that's the same as 1/2. Of course, that's the same as rad 1 over rad 2. And that's the same as 1 over rad 2. Danger, Will Robinson, danger. I have a rad downstairs. I never want a rad in my denominator. So I'm going to multiply by that special form of 1. I'm always choosing to multiply by the thing I want to get rid of. 1 times rad 2 ends up being rad 2. Rad 2 times rad 2, the rads cancel each other out. I'm left with 2. And look at that, I get the same exact answer. 2 really good ways to do it. That doesn't mean those are the only 2 ways to do it. That's just 2 really good ways. Okay, let's take a look here at number 4. And I'm going to do it 2 ways as well. The first way will be to break rad 40 in the numerator up into 4 times 10. That's my numerator. My denominator will be 100 times 2. So now I'm going to have, let's see, 2 rad 10 over square root of rad 100 is 10 rad 2. I can simplify this into 1/5. So I'm going to get rad 10 over 5 rad 2. I have a rad in my denominator, so I have to multiply by rad 2 over rad 2. I don't mind that that the 5 is there. It's okay to have a 5 in my denominator. It's just not okay to have a rad down there. So my numerator is going to now turn into rad 20. But rad 20, I know, is 4 times 5. Yeah, I'm not done simplifying, am I? And then my denominator is going to turn into 5, and these 2 rad 2's will turn into 2, so it's 5 times 10. So my numerator is going to be 2 rad 5. My denominator is going to be 10. And look at this. This is kind of a long problem, but not hard. 2/10 is the same as 1/5. So I'm going to get rad 5 over 5. Wow, kind of cool. Now I'm going to try that the other way, and you can decide which way you think is easier. Oops, wrong button. There we go. The problem was rad 40 over 200. And that will simplify to rad, oops, excuse me. I'm going to simplify my fraction first this time. And I think rad 40 is going to go into 205 times. Pretty sure about that. And that's the same as rad 1 over rad 5. And then I'm going to multiply by rad 5 in the denominator and in the numerator. If I don't do it by both, I'm not multiplying by 1, and therefore I'm changing the number. Rad 1 times rad 5 is rad 5. Rad 5 times rad 5 is 5. So it looks like in this case, it's definitely easier to simplify first. And generally, I find that to make my math easier, simplify my fractions first, and then go ahead and do whatever operation it is. All right, I'm going to end this lesson. I will get to the equations solving in the next lesson. All right, Mr. Lawrence signing off. Have a good night, everybody.